Hey there, Algebra 2 students. Welcome back to Miss McGuire's classroom. Today we're going to be doing Unit 4, Lesson 6. This is part 2 of Lesson 5. So some of the stuff we go over today is going to seem kind of familiar. As always, don't forget to put your first and last name, period, and the date in the upper right-hand corner of your paper. Our topic today is graphing degree 2 polynomial functions, part 2. So this is a continuation, like I said, of Lesson 5. Where we learned all about end behavior, domain, range, for the vertex of a parabola, how to find it. We've talked about the x-intercepts, the y-intercept of parabolas, all that good stuff. But today, you're actually going to learn how to graph them yourself. So the objective today is I will graph degree 2 polynomial functions by identifying key features algebraically as well as key features of the function itself. Mastery will be demonstrated by scoring at least 80% on the extra practice, which is actually a lie. We're going to skip the extra practice and you're going to get at least an 80% on the homework today. All right. So example 1, our directions are identify the vertex, domain, range, end behavior, axis of symmetry, maximum, minimum, y-intercept, and x-intercepts of each function, and then graph it. This is going to be fun. All right. So let's talk about the equation real quick. Y is equal to x squared minus 4x plus 4. This is the function that we want to graph. Well, my leading term is x squared. This term is positive and the degree is even. Because the term is positive, the leading coefficient is positive, and the degree is even, I expect my end behavior to be up and up. So I expect my end behavior to be up and up. And we can identify that without even graphing this parabola. So because I expect my end behavior to be up and up, I expect to have an upward facing parabola. And the stuff we find algebraically should kind of line up with that. We'll see for sure in just a minute. So we have our end behavior up and up. And then because it's a upwards facing parabola, I expect to have a minimum point and a minimum value. So I know that I'm going to have a minimum value. And we're going to figure out what that is in just a minute. All right, let's jump in. So step 1 is to find the vertex and axis of symmetry and then graph them. So remember to find the axis of symmetry to find the x value of our vertex. We always use negative b over 2a, and then we plug that into the function to find the y value of that point. All right, so our equation is y equals x squared minus 4x and then plus 4, right? Plus 4. All right, so our a value is 1, b is negative 4, and c is 4. So our x value of our vertex is negative b over 2a. So the negative of b over 2 times a, b is negative 4, a is 1. So x is equal to the negative of negative 4 is positive 4, 2 times 1 is 2, 4 divided by 2 is 2. So my vertex is going to be at 2 something. Remember, our axis of symmetry is always, our vertex is the point HK. The axis of symmetry is always the line x equals h. So now that I know that my h value is 2, I know my axis of symmetry is x is equal to 2. Now we're going to plug that in to the function to find the y value of our vertex. So we're going to plug 2 in. So y is equal to 2 squared minus 4 times 2 plus 4. So y is equal to 4. 2 squared is 4. Negative 4 times 2 is negative 8 plus 4. Let's see. 4 plus 4 is 8 minus 8 is 0. So y would be equal to 0 at that point. So we have the point 2, 0 as our vertex, axis of symmetry, x equals 2. We're going to graph those two things real quick. Well, before I can graph though, I have to label my graph. Remember, when you label your graph in this class, you have to label the x and y axis. I need dashes at every x and y value. And then you also have to label your scale. For this graph, I'm going to count by 1. So I'm going to have 1, 2, 3, 4, 5, 6. And remember, for your scale, I need at least every other number labeled. If you do not label your graphs, you get an automatic 0. So when you turn your homework in today, if your graphs aren't labeled, even if you graphed everything, even if you found all the right points, I'm still going to give you 0s on your homework because you have to label your graphs. I want you to be able to hand your graph to any person on the street. They should be able to read it, understand what it means. All right, so let's graph our axis of symmetry at 2, 0. Or sorry, our vertex. Let's graph our vertex at 2, 0. Our axis of symmetry is the line x equals 2. So it's just a vertical line that goes through x equals 2, and you want to make sure that you dash your axis of symmetry because it's not part of the parabola. So it's not part of our solution set, but we still want to graph it. All right, step 2, find the x-intercepts and graph them. So remember, to find x-intercepts, you can factor, you can solve by completing the square, or you can use the quadratic formula, whichever one you want. And then remember, y is always equal to 0, no matter what, when you have an x-intercept. So for finding my x-intercept, I'm going to make y 0, x squared minus 4x plus 4. And this might be factorable. I'm going to see if it is. So let's see. Factors of a times c, a is 1, c is 4, so 1 times 4 is 4. Factors of 4, 1 and 4 and 2 and 2. Are there factors of 4 that add or subtract to get me negative 4? I could use 2 and 2. So I'm going to have 0 equals x squared. I'm going to use 2x and 2x and then positive 4. To get negative 4 in the middle, though, I want negative 2 and negative 2. Now I have my 4 terms. I'm going to put the first 2 in parentheses. I'm going to put the second 2 in parentheses with a plus sign in between. So make sure that negative is with the 2 in the parentheses. Then I'm going to factor out an x from x squared and negative 2x. I'm going to factor out a negative 2 from negative 2x and 4, and I'm going to get x minus 2. Hey, our parentheses match. I get 0 is equal to x minus 2 times x minus 2. I set my factors equal to 0. And I solve for x. I get x equals 2 and x equals 2. Well, check it out. X equals 2 twice. So that means that we have multiplicity. Remember the word multiplicity? We have multiplicity of zeros here. So our x-intercepts are 2, 0 with multiplicity of 2. So even though our x-intercept has multiplicity, you only have to graph it once. So we're going to graph 2, 0 once. Well, hey, 2, 0 was also our vertex. So it just so happened to be that our vertex and our x-intercept are the same point, which is perfectly fine and happens sometimes. All right. Step 3, find the y-intercept, graph it, and then reflect it across the axis of symmetry. So this step has like 3 steps in it. Sorry. All right, let's see, we did pink, blue, let's do purple for the y-intercept. So when I graph my y-intercept, I always use x equals 0. So y equals x squared minus 4x plus 4. All we have to do to find a y-intercept is plug in 0 for x. And we get 0 squared is 0, negative 4 times 0 is 0, and plus 4, which is just 4. Our y-intercept is the point 0, 4. Now let's graph it. So my y-intercept would be here. And then check this out. Because the axis of symmetry divides our parabola perfectly in half, if there is a point on the left side of the axis of symmetry that's 2 away, like 2 units away from the axis of symmetry, that means that there's a point 2 units away from it exactly on the other side. So after we graph our y-intercept, we can actually reflect it across and make sure that it's the same distance away from the axis of symmetry on both sides. Now I have some points here that I can figure out the shape of my parabola. I see my vertex is down here, and then it goes up to the right, And then my vertex is down here, and then it also goes up to the left. And I can sketch in my parabola from there using those 3 points. All right, now check it out. What is our end behavior? Well, to the far left, it's up, and to the far right, it's going up as well. So our end behavior was in fact up and up. What's our minimum value? Our minimum value is whatever y is at our vertex. So our minimum value at this point is 0. So our minimum is y equals 0. Then what's our domain? Well, remember your domain is your x values and your range is your y values. Well, for my domain, we've talked about this with parabolas before, because my graph extends to the right forever, even though it's like increasing, so it's going up to the right forever, it's still extending to the right forever though. I know that I'm headed towards positive infinity in that direction. And then to the left, I'm also extending forever. So I'm headed in the negative infinity direction forever as well. So for my domain is then negative infinity to positive infinity. You always list domain least to greatest, okay? Then what about for our range? So for my y values, well, my y values, my parabola doesn't go below the x-axis here. And I don't actually want a dotted line there because it's not an axis of symmetry. But my graph does not go below that point. So that means that my graph extends up forever. And the lowest it can go is at 0 for the y value. And then everything is above that. So I'm going to list my least value first, which is 0. And then we're headed to positive infinity from there. So that would be my range. So what do you think? We just graphed our first parabola in this class. We identified a whole bunch of key features. And that's it. Just a few quick, easy steps. Not too bad, right? All right, let's do another one. So for example 2, what I'm going to do is I'm going to walk you guys through each step and we'll check each step as we go. Don't forget to label your graph, of course. You might want to pause the video and just do that real quick. And then I actually want you guys to find your vertex on your own. So I want you to press pause, only find your vertex and your axis of symmetry. Go ahead and graph them and then press play when you're ready to check step 1. So you're just finding your vertex and your axis of symmetry, and then you're going to press play when you're ready to check them. Give it a shot. All right, so let's compare our vertex and axis of symmetry. I got the point -3, 4, and x equals -3. So let's graph those real quick if you haven't already. So -3, 4 is right here. Don't forget to label your graphs. And then your axis of symmetry is just the vertical line at x equals 3 that goes through your vertex and the x-axis at -3. All right, now I need you to find your x-intercepts and graph them. So don't forget, you need to plug in 0 for y. What's our equation? -x² minus 6x minus 5, right? Yeah. Plug in 0 for y. You can factor it. You can plug it into the quadratic formula. You can complete the square. Whatever you want to do is fine. The first thing I would highly recommend though for this is either divide everything by -1 or factor out a -1. And when you do that, that'll make a positive, which makes it easier to deal with in your equation. All right. All right, press pause, find those x-intercepts, and then press play when you're ready to check your work. So whatever method you may have used, you should still have the x-intercepts, the same x-intercepts that I found. I found x equals -5 and x equals -1 for my roots. So my x-intercepts would be at -5, 0 and -1, 0. So I'm going to plot those at -5, 0 and -1, 0. All right. Now let's find our y-intercept and graph it, and then reflect it across the axis of symmetry. So for step 3, don't forget to use x equals 0. and just plug that in to our function. Press pause and then press play when you're ready to check your work. Give it a shot. All right, for my y-intercepts, I found 0, -5. So when I plot that, I'm going to have a point at 0, -5. I see that this point is 3 away, 1, 2, 3 spaces from our, or 3 units from our axis of symmetry. So I'm going to go 1, 2, 3 units in the opposite direction and reflect that point. And I see my parabola shape start to merge here because my vertex is up here, and then to the left, I'm going down. Make sure it's a U shape. You want it to be rounded. And then to the right, I'm also headed down. So check it out. Our end behavior then is down and down. Could we have figured that out though, just by looking at the equation? Our leading term is -x². Our leading coefficient is negative and our degree is even. So shouldn't we expect our end behavior to be down and down? All right, then go ahead and press pause and press play. I want you to tell me if we have a minimum or a maximum, what that value is. I want you to tell me about the domain and range. So press pause and then press play when you're ready to check your work. So we have a maximum value because the whole parabola is underneath this point here, and it goes down from there. So we have a maximum value at y = 4. Notice your maximum value or your minimum value always matches the y value of the vertex. Okay. And then our domain is -∞ to +∞. It extends to the right and to the left forever. And then for our range, our max value is 4. So remember, we always want to list our least value to our greatest value. So if our max value is 4, 4 is going to be on the right. And then it goes down from there forever. So it goes to -∞ to 4 for our range. All right, I hope you all did a great job on that. Let's do some more. So example 3, y is equal to x² plus 3x minus 4. This time, I want you to try to find more pieces of this graph on your own. So I want you to do step 1, step 2, and step 3 without me. So I want you to press pause and then press play when you're ready to check step 1, 2, and 3 of your graph. No cheating, no peeking. Give it a shot. See how far you can get without me, okay? Don't forget to label your graphs. Good luck. All right, so hopefully you kind of figured some of this out. I hope none of you got tripped up by step 1, finding the vertex, which actually happened to be decimals, which is perfectly fine. So when we're graphing, it's okay to change a fraction to a decimal. So that -3/2 is really -1.5. And changing it to a decimal is fine when you graph, just so you know exactly where it goes when you plot the point. I plugged in -1.5 into the function, and I got y = -6.25. which gave me a vertex at -1.5, -6.25, and an axis of symmetry of x = -1.5. For my x-intercepts, I was able to factor this problem, and then I found that x is equal to -4 and 1 for my zeros. So my x-intercepts are at -4, 0, and 1, 0. Then for my y-intercepts, I plugged in x = 0, and I found y, and it ended up simplifying to -4. So my y-intercept is at 0, -4. Have any of you noticed that our y-intercept is always the value of c? Interesting. Okay, so then I plotted all those points. I plotted my vertex at -1.5 and -6.25. I plotted my x-intercepts. I plotted my y-intercept, and then I flipped it over the x-axis or reflected it. And then I also just put that vertical line through my vertex, which is my axis of symmetry. at x equals negative 1.5. All right, let's describe this. So because it's a facing upwards parabola, I have a minimum. And that minimum is that y is equal to negative 6.25. My end behavior is up and up. Our domain is all real numbers because the graph extends to the far left and the far right forever. And then our range is, let's see, the least value is that negative 6.25. And then it extends upward forever to infinity. All right. All right, let's jump to example 4. So example 4, y equals x squared minus 5x plus 7. Because my leading term is positive and my degree is even, I'm expecting my end behavior to be up and up. And something interesting is going to happen with this equation. It is not going to cross the x-axis in the real number plane. So let's see what happens. All right, let's do our vertex here. So to find our vertex, we use x is equal to the negative of b over 2 times a. So negative of negative 5 is 5 over 2. 5 divided by 2 is 2.5. Okay. Then let's find our y value. So y will be equal to, let's see, x squared minus 5 times x plus 7. So we're going to plug in 2.5. Right. I don't feel like doing any of that in my head, so we're going to use a handy dandy calculator. 2.5 squared is 6.25 minus 5 times 2.5 is 12.5, and then we're going to add 7. So 6.25 minus 12.5 plus 7 is 0.75. And then our axis of symmetry is x is equal to 2.5. Don't forget to label your graph, your x and y axes, and all of your scale. So our vertex is at 2.5 and 0.75, so just under 1. And then our axis of symmetry is just that vertical line that goes through that point. Okay. Now let's find our x-intercepts. So to find our x-intercepts, let's see, our equation is, so 0 equals x squared minus 5x plus 7. Okay. All right, so 7 times 1 is 7, and then the only factors of 7 are 1 and 7. So this isn't factorable because 1 and 7 don't add or subtract to get negative 5, which means we're going to have to use the quadratic formula, or we could complete the square. But for this problem, the quadratic formula is like the path of least resistance. So let's do this. X is equal to the negative of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So a is 1, c is 7, b is negative 5. The negative of negative 5 is 5. Negative 5 squared is 25. 4 times 1 times 27 is negative 28, all over 2. Right. So then we get x is equal to 5 plus or minus the square root of negative 3 all over 2. So remember, we can simplify that by replacing the negative 3 with negative 1 times 3. Negative 1 is really 5i squared. I don't know why I said 5i squared. So we can bring out an I over 2. All right. So our x-intercepts are going to be at the point 5 plus or minus I root 2 over 2, 0. But because there's an I in these points, that means that these are on the imaginary number plane and we can't graph them on the real number plane. So we're actually done with our x-intercepts. We have nothing to graph because we're on the real number plane. We don't have any i's here. We're not on the imaginary number plane, so we're good. All right, now we need to find the y-intercept. So we always, whenever we find a y-intercept, we always use x equals 0. So we're gonna have y is equal to 0 squared minus 5 times 0 plus 7, which is 0 squared is 0, negative 5 times 0 is 0, plus 7, y equals 7. So we have the point 0, 7. So let's graph that. So 0, 7 is up here. And then remember, we need to reflect it. So it's 1, 2, and a half. So a half, 1, 2. And then I see a shape of a parabola that extends up from the vertex to the right and then up from the vertex to the left. And check it out. Our end behavior is up and up, just like we expected. All right. So now, does our graph have a minimum or a maximum? What is that y value? What's the domain and what's the range? Why don't you identify those 2 things or 3 things for me real quick? Press pause and then press play when you're ready to check your work. So this graph has a minimum at y equals 0.75. Our domain is negative infinity to positive infinity, and our range is 0.75 to infinity. All right, so now I want you to try example 5, all on your own. I want you to do this whole thing by yourself. Now notice your leading coefficient, your leading term has a negative coefficient and an even degree. So what do you expect the end behavior to be? So think about that while you make the graph. And then work your way through step 1, step 2, and step 3. If you can't factor for step 2, remember you can always use the quadratic formula. If you need help while you do this, you can always hit the ask for help button. I'll jump into your breakout room and go over the problem with you. If you have questions, let me know. Yeah, press pause and then press play when you're ready to check your work. Good luck, you got this. All right, let's check your work. So for step 1, I found that my vertex is 1.5, negative 1.75, and my axis of symmetry is x equals 1.5. For step 2, I found imaginary zeros. So I know I'm not going to be graphing them on my real number plane. For step 3, I found my y-intercept as 0, negative 4. So let's plot those points. Let's see, my vertex was at 1.5 and negative 1.75. So here, I have a y, sorry, let's do our axis of symmetry. There we go. No real x-intercepts. And so I'm going to have a y-intercept at negative 4. I'm going to reflect that to there. And then I'm going to sketch in my parabola. There we go. All right, so it looks like this parabola, because it's face down, it has a maximum at y is equal to negative 1.75. My end behavior is down and down. My domain is negative infinity to positive infinity. My range is negative infinity to negative 1.75. Now, I want to point something out real quick before we end this lesson. And that is, if you find your vertex at 1.5, negative 1.75. So I'm going to erase my parabola for a quick second. If you find your vertex and it's 1.5, negative 1.75. It's right there. Now, by looking at this leading term that has a negative coefficient and an even degree, that tells me that this graph is going to be down and down, right? My end behavior, sorry, will be down and down. That means that this graph from this point, wherever it goes from this point, has to extend down and down. If it has to extend down and down from that point, can it cross the x-axis? No. So because it's never going to cross the x-axis, that already tells me that I am not going to have x-intercepts that I need to worry about graphing. So that's a way that we can know that our x-intercepts like are imaginary and that we're on the right track algebraically, just by looking at the equation and finding the vertex. All right, I'm gonna put that back. And make sure your parabolas are a smooth curve. All right, so now you actually need to get started on your homework. It's on Schoology tonight, not on Math Excel. You're going to self-grade it and turn in the graded version. And if you need help, of course, just hit that ask for help button and I'll jump into your breakout room and work with you. All right, have a good day. I'll see you back in class.